When dealing with grounding disconnects to a meter can in a residential application, it is important to adhere to the National Electrical Code, or NEC, guidelines. The question addresses a scenario where there's an existing 200 amp disconnect fed by a 400 amp, also known as a 320 continuous amp meter can. The grounding wire runs from two ground rods spaced 6 feet apart, connecting to the neutral bonding lug of the meter can and then extending to a double lug on the ground bolt within the meter can. The existing disconnect panel's ground wire is also connected to one hole of this double lug. The question is whether a new disconnect ground can be connected to the same hole of the double lug as the first disconnect ground. The answer is yes, connecting the new disconnect ground to the same hole of the double lug is permissible. The NEC allows multiple grounding electrodes, such as ground rods, to be connected together to enhance grounding effectiveness. These connections are typically made to a common grounding bus or lug. In the described setup, the two ground wires from the ground rods are already connected to a double lug on the ground bolt inside the meter can. This lug acts as a common grounding point for both the neutral bonding jumper and the ground wire from the first disconnect panel. Connecting the ground wire from the new disconnect panel to the same hole of the double lug establishes a parallel path for the ground current, which is acceptable and a common practice. It is important to ensure that all connections are tight and secure and that the grounding conductors meet the minimum size requirements specified in the NEC. Understanding grounding electrode systems. Grounding electrode systems are crucial for electrical safety. They provide a low impedance path for fault current to return to the source, which helps to trip over current protection devices like circuit breakers or fuses. Grounding electrodes are typically made of materials like copper or galvanized steel and are buried in the earth to establish a connection to ground. Common types of grounding electrodes include ground rods, ground plates, and metal underground water pipes. Ground rods are typically driven into the earth at least 8 feet deep, while ground plates are buried horizontally. When using a metal underground water pipe as a grounding electrode, it must be supplemented by an additional electrode, such as a ground rod or ground plate. The NEC outlines specific requirements for the size and installation of grounding electrodes to ensure their effectiveness. Connecting multiple grounding electrodes. In many situations, multiple grounding electrodes are used to improve the overall grounding system. This can be particularly important in areas with high soil resistivity or where a single grounding electrode may not provide adequate grounding. The NEC allows for the connection of multiple grounding electrodes to create a more robust grounding system. When connecting multiple grounding electrodes, it is important to use appropriately sized grounding electrode conductors. These conductors must be sized according to the NEC guidelines based on the size of the service entrance conductors. The grounding electrode conductors should be connected to a common grounding bus or lug to ensure that all grounding electrodes are effectively bonded together. Bonding jumpers are used to connect different metallic parts of an electrical system to ensure that they are all at the same electrical potential. This helps to prevent voltage differences that could create a shock hazard. Bonding jumpers are commonly used to connect metal enclosures, raceways, and equipment grounding conductors. The NEC specifies the minimum size requirements for bonding jumpers based on the size of the circuit conductors. It is important to use the correct size bonding jumpers to ensure that they can effectively carry fault current. Bonding jumpers must be securely connected to the metallic parts using appropriate connectors or methods. Equipment grounding conductors or EGs provide a path for fault current to return to the source in the event of a ground fault. EGC are typically made of copper or aluminum and are run along with the circuit conductors. The NEC requires that EGC be installed in all electrical circuits to protect against shock hazards. EGC must be properly sized based on the size of the circuit conductors and must be securely connected to all metal enclosures and equipment. Types of grounding systems. There are several types of grounding systems commonly used in electrical installations, including grounded systems and ungrounded systems. Grounded systems have a neutral conductor that is intentionally connected to ground, while ungrounded systems do not have a neutral conductor connected to ground. Grounded systems are more common in residential and commercial applications because they provide better protection against shock hazards. Ungrounded systems are typically used in industrial applications where continuity of service is critical. Grounding in residential applications. In residential applications, grounding is essential for protecting occupants from electrical shock hazards and preventing damage to electrical equipment. The grounding system in a residential building typically consists of a grounding electrode system, a grounding electrode conductor, bonding jumpers, and equipment grounding conductors. The grounding electrode system usually includes ground rods, a metal underground water pipe, or a concrete encased electrode. The grounding electrode conductor connects the grounding electrode system to the neutral busbar in the main service panel. Bonding jumpers are used to connect metal enclosures, raceways, and other metallic parts of the electrical system. Equipment grounding conductors are run with the circuit conductors to provide a path for fault current to return to the source. NEC requirements for grounding. The NEC provides detailed requirements for grounding electrical systems to ensure safety and prevent electrical hazards. Some of the key NEC requirements for grounding include the following: grounding electrode system. The NEC specifies the types of grounding electrodes that are permitted and the requirements for their installation. Grounding electrode conductor. The NEC outlines the minimum size requirements for grounding electrode conductors based on the size of the service entrance conductors. Bonding jumpers. The NEC specifies the minimum size requirements for bonding jumpers and the methods for connecting them to metallic parts. Equipment grounding conductors. The NEC requires that equipment grounding conductors be installed in all electrical circuits and be properly sized based on the size of the circuit conductors. Ground fault protection. The NEC requires ground fault protection for certain types of electrical equipment to prevent electrical shock hazards. Ensuring proper grounding. To ensure proper grounding in an electrical system, it is important to follow the NEC guidelines and best practices. Some tips for ensuring proper grounding include the following: use appropriately sized grounding conductors, bonding jumpers, and equipment grounding conductors. Make sure all connections are tight and secure. Inspect the grounding system regularly to identify and correct any issues. Use a ground resistance tester to verify the effectiveness of the grounding system. Consult with a qualified electrician if you have any questions or concerns about grounding. Common grounding mistakes. Some common grounding mistakes to avoid include the following: using undersized grounding conductors or bonding jumpers, failing to properly connect grounding conductors to metallic parts, neglecting to install equipment grounding conductors in electrical circuits, ignoring the NEC requirements for grounding, overlooking the importance of ground fault protection. By avoiding these common grounding mistakes and following the NEC guidelines, you can help ensure the safety and reliability of your electrical system. Specific considerations for disconnects. When grounding disconnects, several specific considerations should be taken into account. Disconnects are used to isolate electrical circuits or equipment for maintenance or repair purposes. It is important to ensure that disconnects are properly grounded to prevent electrical shock hazards. The NEC requires that disconnects be grounded using equipment grounding conductors. These conductors must be sized according to the size of the circuit conductors and must be securely connected to the metal enclosure of the disconnect. In some cases, it may be necessary to install additional grounding electrodes near the disconnect to improve grounding effectiveness. This can be particularly important in areas with high soil resistivity or where the disconnect is located a significant distance from the main grounding electrode system. When installing grounding electrodes near disconnects, it is important to follow the NEC guidelines for their placement and installation. Grounding and bonding of metal enclosures. Metal enclosures are commonly used to house electrical equipment and protect it from the environment. It is important to properly ground and bond metal enclosures to prevent electrical shock hazards. Grounding metal enclosures involves connecting them to the equipment grounding conductor system. This provides a path for fault current to return to the source in the event of a ground fault. Bonding metal enclosures involves connecting them together using bonding jumpers. This ensures that all metal parts are at the same electrical potential and prevents voltage differences that could create a shock hazard. The NEC specifies the minimum size requirements for grounding and bonding conductors used to connect metal enclosures. Grounding and bonding of electrical equipment. Electrical equipment, such as motors, transformers, and generators, must be properly grounded and bonded to ensure safety and prevent electrical hazards. Grounding electrical equipment involves connecting it to the equipment grounding conductor system. This provides a path for fault current to return to the source in the event of a ground fault. Bonding electrical equipment involves connecting all metal parts together using bonding jumpers. This ensures that all metal parts are at the same electrical potential and prevents voltage differences that could create a shock hazard. The NEC specifies the minimum size requirements for grounding and bonding conductors used to connect electrical equipment. Grounding and bonding in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Electrical equipment used in hazardous locations must be specially designed and installed to prevent ignition of these materials. Grounding and bonding are particularly important in hazardous locations to minimize the risk of electrical sparks. The NEC provides detailed requirements for grounding and bonding in hazardous locations. These requirements include the use of intrinsically safe circuits, explosion-proof enclosures, and special grounding and bonding techniques. Grounding and bonding of sensitive electronic equipment. Sensitive electronic equipment, such as computers, servers, and medical devices, can be susceptible to damage from electrical noise and transients. Proper grounding and bonding are essential for protecting sensitive electronic equipment from these disturbances. The NEC recommends using isolated grounding systems for sensitive electronic equipment. Isolated grounding systems provide a separate grounding path that is isolated from the normal equipment grounding system. This helps to minimize electrical noise and transients that could interfere with the operation of the equipment. Grounding and bonding of communication systems. Communication systems, such as telephone, data, and cable television systems, must be properly grounded and bonded to prevent electrical hazards and protect equipment from damage. The NEC provides specific requirements for grounding and bonding communication systems. These requirements include the use of grounding electrodes, bonding jumpers, and surge protective devices. Surge protective devices, also known as SPD, are used to protect electrical equipment from voltage surges caused by lightning or other events. SPD are typically installed at the service entrance and at branch circuits to provide comprehensive protection. The NEC requires that SPD be properly grounded to ensure their effectiveness. Grounding and bonding inspections. Regular inspections of grounding and bonding systems are essential for ensuring their continued effectiveness. Inspections should be performed by qualified electricians who are familiar with the NEC requirements for grounding and bonding. During an inspection, the electrician will check the condition of grounding conductors, bonding jumpers, and grounding electrodes. They will also verify that all connections are tight and secure and that the grounding system is properly sized. Grounding and bonding troubleshooting. If problems are discovered with the grounding or bonding system, it is important to troubleshoot them promptly to prevent electrical hazards. Common grounding and bonding problems include loose connections, corroded conductors, and undersized grounding conductors. Troubleshooting grounding and bonding problems may require the use of specialized test equipment, such as a ground resistance tester or a clamp-on ammeter. Grounding and bonding safety tips. When working with electrical systems, it is important to follow safety precautions to prevent electrical shock hazards. Some grounding and bonding safety tips include the following. Always disconnect power before working on electrical equipment. Use insulated tools when working on electrical systems. Wear appropriate personal protective equipment, such as gloves and safety glasses. Never work on electrical systems in wet or damp conditions. If you are not qualified to work on electrical systems, hire a licensed electrician. The importance of proper grounding and bonding in electrical systems cannot be overstated. By following the NEC guidelines and best practices, you can help ensure the safety and reliability of your electrical system and protect yourself and others from electrical hazards. These principles, when applied correctly, maintain safe and functional electrical installations. Remember to consult the latest edition of the NEC and local codes for specific requirements in your area.